All right, today for lesson 8-6, we're going to be talking about some different types of angles and circles. And I just wanted to give a kind of an overview of some of the angles that we've already learned as well to kind of help this all just go together today. So we will actually finish, if you guys have your formula sheet, the bright yellow formula sheet that I handed out last week, we're going to kind of go over it. We're going to finish talking about all of the different arcs and angle measures and circles. So we'll have one side of the formula sheet all taught to you. So central angles, this was our lesson 8-3 when we talked about central angles. And the main thing that you want to know, and we actually went through this as a class and even wrote some numbers on here to help us. But when you've got a central angle, it means that your angle has the vertex right here at the center of the circle. The measure of that angle, that central angle, so say this was 97 degrees right here, is the exact same as the measure of its what we call intercepted arc. So the arc that goes from its endpoints right here, that measure of that arc length is also 97 degrees. Okay, so this was lesson 8-3. I also told them if they wanted to write that down so they remembered where to look or use this for 8-3. Central angles was key star of 8-3. 8-4, we learned about inscribed angles. So inscribed angles are angles that have the vertex on the circle. So this one is at the center, this one is on the circle, and its angle measure, so what does this look like? 35 degrees maybe, I think is the one that we used in class today. So that measure of ABC is actually not the same measure as its included arc. It is smaller. So it is half of what arc AC is. The angle is half as small as the arc is twice the measure of the angle. So if this angle is 35, this arc is 70 degrees. Okay, so that was 8-4. 8-3 central angles, 8-4 inscribed angles, vertex is now on the circle. Now, also in 8-4, these next few come from 8-4 as well. We just learned a few tricks. Really, it kind of all ties back to this inscribed angles. But if we have what they call interlapping arcs, so let's see which angles they're looking at, ABD. So if you look at this lovely inscribed angle, again, this is 8-4 inscribed angle, right here, we know that this angle is half the measure of its what we call intercepted arc. So the arc that goes from the endpoints between A and D right there. That angle is half of whatever that lovely arc was. Now, what these overlapping arcs say is there is another angle that has that same intercepted arc. So if you look right here at the measure of ACD, look at this lovely angle right here. It also has the same intercepted arc between A and D. So what this means, if they have the same intercepted arc, then those angles are congruent. We don't even need to know what the arc is. You could just say those angles are congruent. All right, this next one as well also came from 8-4. So we're going to write 8-4 right here. And again, this is all talking about inscribed angles. But when you look right here, let's take A first. If you look at this angle A right here, we're going to go there. Its intercepted arc is just the arc that goes between points B and wraps around through C to D. That's its intercepted arc. So it is half, this angle is half of that measure. Well, when you look at angle C, though, look over here at angle C. Here's angle C. Angle C also has an intercepted arc that goes from B to D, but this time this one goes through A. It goes this other side, so it's going to wrap around here and go to D. So this angle C is half of that arc. So these inscribed quadrilaterals, when we have four sides right here, the opposite sides are what we call supplementary, because notice if you add them together, they're going to be half of their included arcs, which went all the way around the circle, or 360 degrees. So when you add them together, they're going to be half of 360. They're going to add to 180 degrees. Same thing with B and D. So you could go ahead and throw some numbers in here just to kind of help you. Maybe you could say 100 degrees and this is going to be 80 degrees. So opposite angles in a quadrilateral, so a four-sided figure is inscribed in a circle, the opposite angles are supplementary right there. All right, so that was just a review. Now, what we're learning today is these next 5. I know we get a whole lot of them today, but I think that you'll realize and learn, hopefully, as we go through this, that they kind of tie together. You'll see some similarities here. So this is 8-5, 8-5, and let's do this. 8-5 down here, 8-5, and 8-5. Okay, and before I get into the examples on the other page, probably even another video, we'll just do this as a quick short introduction video. Please note, these are different from central angles. These angles right here that we're looking at, they're looking at angle 1 and angle 2. They do not intersect at the center of the circle. This is not the center of the circle. If it was, they would put a point there. I just put a point there, so I should probably erase it. Let me grab the eraser. This point is not the center of the circle. So a lot of people try and say, well, angle 1 is whatever AB is. But remember, angle 1 right here, its vertical angle is over here. Those two angles are the same. That would go to say that these two measures are the same. But look, that one is smaller than this one. Okay, you can't maybe tell so much on this, but if it were closer, they're smaller. They're not the same size, so we're going to learn a new formula for this one and all the rest. I just kind of wanted to give you an overview of what we've learned so far. So click to the next video to start our notes.